So chapter 4, we're going to be talking about angles of triangles, and that's going to eventually lead us into triangle congruences. So when we talk about the triangle angle sum theorem, it says that the sum of the angles of a triangle is 180. So that is the most important thing. All angles in a triangle add up to 180 degrees. So this theorem can be used to find the measures of a missing angle of a triangle if you're given two of the three angles. So you can certainly have something very basic, or you can have something where you have multiple triangles going on at once. So that's what you see with 1 and 2. So if I take this triangle on the right-hand side, the reason I'm focusing on that one is because I have 2 out of those 3 angles. So 57 plus 71 plus angle 2 equals 180 because it's a triangle. And if you solve for that, you end up with angle 2 equaling 52 degrees. Okay? Now, if we're trying to find the measure of all of the angles, well, we have to use a little bit of information here. So we have 57 right here, and then we have angle 1 next to it. Well, we know that angle 1 plus the 57, they make a line, so they're equal to 180 degrees. So that means angle 1 is equal to 123 degrees. So we've got angle 1, and we found out angle 2. Now for angle 3, I'm going to use the triangle on the left-hand side because now I have 2 out of those 3 angles. So angle 3 plus 28 plus 123 equals 180, which means that angle 3 is equal to 29 degrees. Okay, so you got to do one at a time, and again, it does not need to go in the same order or the order of the numbers normally go in. All right, let's look at number 2. So I'm going to look at triangle on the right first. And I'm going to say, okay, well, I need more room here. So let's see. So I have angle 7 plus 58 plus 65 equals 180. So that means that angle 7 is equal to 57 degrees. Well, if 7 is 57 degrees, then I know that 5 is 57 degrees because they're vertical angles. So I can put 57 in here. Then I'm going to use this triangle right here, the other bow tie part to it, or butterfly, or bow tie, either one. And I see that angle 4 plus my 57 plus 67 equals 180. So that means angle 4 is 56 degrees. And now I've got to get 6, 8, and 9. So 6 makes a straight line with 7. So that means that angle 6 plus the 57 degrees for 7 equals 180. So that means 6 is equal to 123. So this is 123. And then if I look at that bottom triangle right there, you also notice that 8 and 9 are equal to each other. So if I make this also equal to 8, they're going to be equal to the same thing. So I can say that, put it over here, angle 8 plus another angle 8 plus 123 equals 180. So that means 2 times angle 8. If I subtract the 123 from 180, that's going to end up giving me, take 123 away, 10, 7, that gets me 57 degrees. And then I'm going to divide by 2. So that means angle 8, not a perfect number, but that's fine. You get 28.5. And then just based on the diagram, I know 9 is equal to the same thing. Okay, because it's an isosceles triangle. So it says in addition to its 3 interior angles, so that's inside the triangle, a triangle has exterior angles that are formed by one side of a triangle and the extension of an adjacent side. Each exterior angle of a triangle has 2 remote interior angles. So if I draw a triangle and I label the angles 1, 2, and 3, if I extend each of these sides out to make a new angle, which would now be my exterior angles, my interior angles are 1, 2, and 3. My exterior angles are 4, 5, and 6. So if we now use this new theorem, it says we have the exterior angle, and then we have the remote interior angles that go with it. So exterior, we have 4, 5, and 6. And by remote interior angles, that's an angle that is not next to that angle. Okay, so 4, if we look at 4 right here, 1 is next to it. So keep in mind, it's remote interior, so it has to be inside the triangle. So the only options we have are 1, 2, and 3. So if 1 is next to 4, that means that 2 and 3 would be the 2 remote interior angles for angle 4. For angle 5, 2 is next to it, which means angle 1 and angle 3 would be the remote interior. And for 6, 3 is next to it, so that means 1 and 2 would be the remote interior angles. Now the measure of the exterior angle, it's equal to the sum of the measure of the 2 remote interior angles. So if we look at that diagram on the right, our exterior is angle 1. The one next to it cannot be the remote interior, so that means one remote interior is A, the other one is going to be angle B. And what this theorem says, it says that the exterior angle is equal to the sum of the 2 remote interior angles. So angle 1 is equal to angle A plus angle B. All right, so let's apply a little bit of algebra with these now. So after each one, I'm going to go back and erase it. So just make sure that you're using a pencil when you're filling this stuff in. So it says angle 2 is 38 degrees and angle 4 is 134. And we are finding 5. So there's our x. Well, 4 is an exterior angle. And based on the information that we know, we learned the theorem that says the exterior angle, angle 4, is equal to the sum of the 2 remote interior angles. Well, the 2 remote interior angles according to angle 4 would be angle 2 plus angle 5. So that's the sum. So let's sub in. Angle 4 is 134. Angle 2 is 38. And angle 5, we don't know. And when we solve, we get x to be equal to 96. So you could say that angle 5 was equal to 96 degrees. All right, let's erase these and do it again for number 2. All right, so it says angle 2 is x plus 17, 3 is 2x, and 6 is 101. Well, 6 is an exterior angle, so the exterior angle is equal to the sum of the 2 remote interior angles, which in this case would be 2 and 3. So 6 is 101, 2 is x plus 17, and 3 is 2x. So 101 equals 3x plus 17. When you subtract and then solve, you get x to be equal to 28. So if we are looking for angle 3 is equal to 2x, so 2 times 28 gets us 56 degrees for that. All right, one more. Let's erase these guys. All right, so we have 2, we've got 3, and we've got 6. So same one we just did above. So 6 is equal to 2 and 3, because those are their remote interior. 6 is 98, 2 is 3x, and 3 is x plus 34. So 98 equals 4x plus 34, which solve for x is 16. And then angle 2 is 3 times x, which 3 times 16 would then get us 48 degrees for that. So 2 more corollaries that go with this, and then 1 more set of practice down at the bottom there. So it says the acute angles of a right triangle are complementary. So we know, so we can say that we know angle A plus angle B plus angle C equals 180. That we're sure of. But it's telling us that C is a right angle. So we can say that but angle C equals 90. So what that means is that angle A plus angle B, put those two together, that also has to equal 90 degrees, which matches with the word complementary, which means 90 degrees. Corollary 2 says there can be at most one right or obtuse angle in a triangle. So when we talked about different kinds of triangles, a right triangle can only have one right angle, and an obtuse triangle can only have one obtuse. Because think the total of the 3 put together have to be 180. So if they're anything more than those, you're not going to be able to make a triangle. All right, last 3 on the bottom. So it says we want angle 2, angle 3, and angle 4. So let's see if we could fill some stuff in here. So I'm just going to highlight the right angles a little bit more. And we're going to focus on one triangle at a time. So I'm going to focus on this guy right here. Keep in mind, anywhere you see that little box, that means 90. So angle 2 plus 90 plus 38 equals 180, which means that angle 2 is equal to 52 degrees. So we got that one. Now, if you look where 3 and 2 are, 3 and 2, well, they make up a right angle. So that means that angle 2 plus angle 3 equals 90 degrees. Well, angle 2 we just said was 52. Angle 3 is what we're solving for. So when we solve, we get angle 3 equal to 38 degrees for that one. So that's 30.